Hello everyone, today we are going to look at a leetcode problem called product of array except self. Given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. And you must write an algorithm that runs in O of n time without using the division operation. And let's look at the examples. The first example, when nums equals 1, 2, 3, 4, the output is 24, 12, 8, 6. 24 is calculated by multiplying the second, third, and fourth number in nums, which is 2 multiplied by 3 and multiplied by 4. 12 is calculated by multiplying the first, third, and fourth number. 8 is calculated by multiplying the first, second, and fourth number. 6 is calculated by multiplying the first, second, and the third number. So as you can see, each number in the output is calculated by multiplying all the elements in nums except nums I. One way to solve the problem is to calculate the answer for each number. And when calculating the answer for each number, you need to iterate through nums and multiply everything except the current number. Take 1, 2, 3, 4 as an example. When calculating the answer for the first number, you need to multiply the last three numbers. When calculating the answer for the second number, you need to multiply the first, the third, and the fourth number. And similarly, when calculating the answer for the third number, you need to multiply the first, the second, and the fourth number, and so on. The time complexity of this method would be O of n squared, because we need to iterate through the nums array twice. We need the first iteration because we need to calculate the answer for each number. We need the second iteration because for each number, we need to multiply all the numbers in nums except self. Is there any faster method? Yes, you can split the answer for each number into two parts, prefix and suffix. Take 1, 2, 3, 4, 5, 6, 7 as an example. The prefix of the fourth number will be 1 multiplied by 2 multiplied by 3. The suffix of it will be 5 multiplied by 6 multiplied by 7. And in the end, we can just multiply prefix with suffix to get the final answer. Notice that the first number doesn't have prefix, but we can set its prefix to 1, so when multiplied by suffix, we can still get the correct answer for the first number. The same goes for the last number, whose suffix should be 1. But how can prefix and suffix help us accelerate the calculation? Notice that the prefix of each number can be used to calculate the prefix of its following numbers. So we can store the calculated prefix in each step and reuse it when calculating the next number's prefix. We can do the same to suffix too, only that we should calculate suffix from the last number to the first one. If you don't understand, let's take 1, 2, 3, 4 as an example. We initialize prefix to 1, which is the prefix of the first number. Let's call it P1. And the prefix of 2, which is P2, equals P1 multiplied by 1. The prefix of the third number, P3, equals P2 multiplied by 2. The prefix of the fourth number, P4, equals P3 multiplied by 3. So, as you can see, We only need the time complexity of O of n to calculate the prefix for each number. If you're still confused, we will jump to the coding session and illustrate the process step by step so you can understand why the time complexity of this method is lower. Now let's code. Let's first define the prefix variable and initialize its value to 1. Then we create the result array, which is going to be returned at the end of the method. We then iterate through the nums array. And in each iteration, we store the previous prefix in result I and calculate the current prefix by multiplying it with the current number nums I. That's how we calculate prefix. Notice that the code is incomplete for now. We will calculate suffix before long. So let's go through the process step by step so you can understand it better. In the first iteration, result 0 is 1. Prefix is nums 0. In the second iteration, result 1 is prefix, which is nums 0. Prefix becomes nums 0 multiplied by nums 1. In the third iteration, result 2 becomes prefix, which is nums 0 multiplied by nums 1. And prefix becomes nums 0 multiplied by nums 1 multiplied by nums 2. And in the fourth iteration, result 3 equals prefix, which equals nums 0 multiplied by nums 1 multiplied by nums 2. And prefix becomes nums 0 multiplied by nums 1 multiplied by nums 2 multiplied by nums 3. So as you can see, the prefix of each number is stored in the result array. Result I denotes the prefix of nums I. For example, result 0 is the prefix of the first number. Result 1 is the prefix of the second number. Result 2 is the prefix of the third number, and the result 3 is the prefix of the fourth number. Now we've calculated prefix and stored them in result I. If we can multiply result I by its suffix, then we can return results. It's what the problem demands. To do that, we first initialize suffix to 1. Then we iterate through the array again. This time we start from the last number. As before, we multiply result I by the previous suffix. Then calculate suffix by multiplying it with the current number nums I. That's it. That is the complete code. Let's go through the second for loop step by step so you can understand it really works. Suppose we have 4 numbers in nums. Then in the first iteration, result 3 will become the original result 3 multiplied by suffix, which is equal to nums 0 multiplied by nums 1 multiplied by nums 2. Suffix would be nums 3. And in the second iteration, result 2 will become the original result 2 multiplied by suffix, which is equal to nums 0 multiplied by nums 2 multiplied by nums 3. And the suffix would become nums 2 multiplied by nums 3. In the third iteration, result 1 will become the original result 1 multiplied by suffix, which is equal to nums 0 multiplied by nums 2 multiplied by nums 3, and the suffix will become nums 1 multiplied by nums 2 multiplied by nums 3. And I will omit the fourth iteration here. As you can see, each number in the result array equals the product of all the numbers in nums except itself, which is what the problem demands. So we can just return result, and the problem is solved. Let's submit this solution. Sorry. Let's submit it again. Okay, you can see that the speed of the solution is pretty fast, and the memory cost is low.